Hi all, welcome back to another session on web methods. So in this session would be mostly theory. It's about the scaling in web methods. So you might have all heard these terms in your projects where they say scale up, scale down, and all those things. What is scaling actually? So scaling is nothing but to increase the resources, or scale up is like increase the load or increase the resources used in performing the day-to-day operations. And scale down, it's like bringing down the resources in bringing down the scaled up resources. So there are two types of scaling strategies. One is horizontal scaling and the vertical scaling. So horizontal scaling is nothing but adding more instances or nodes to a system to distribute the workload and to increase the capacity. So in other words, so if you have integration server installed in one integration server installed in your system, so it is handling certain amount of load in one system. So let's assume that if the load is, we assume that we'll be getting only 100K orders per week or something. But due to the business increasing further, we are getting 200K orders per day, per week, sorry. So in that cases, what you generally do, what we do is we add more VMs to it and make sure that the load is evenly distributed between between them, so that the incoming load that is coming up is handled properly. But if you see, this is one kind of advantage where it is easier to add more machines. And if let's say if one even if one node fails, the other node will be still be up and running. And but the disadvantage is like the cost involved in yeah, scaling up the servers. Like you need to have additional licenses, and additional cores need to be built up, and you need to install all this uh, replicate all the resources that you have installed in one of the server, and make sure that it is having all the resources needed. And let's assume that tomorrow there is silent period. So in that case, you need to bring down the the additional purchased resource. And if it is scaling down further, the cost involved in setting up the new server is, it's anyway, it's like it's a burden, and it is harder to maintain because you need to install the patches in both the VMs, and you need to install the antiviruses in both the systems, and you need to maintain all those things. So horizontal scaling, it has its advantages and it also has its advantages, which involves advantages like it is scalable and it is fault tolerant and it is cost effective. When I say cost effective, it's like if you have two or more servers, that is fine. But if it keeps on increasing, it is harder to maintain. And now comes the other scaling method, which is vertical scaling. Vertical scaling is nothing but increasing the capacity of single instance or node by adding more resources such as CPU, RAM, or storage. So let's say if you have installed integration server. So in this, we are using, say, you have the capacity of 8 GB RAM. So then what you will do? So in this vertical scaling, let's say if the load is increasing, so it takes the load up to 8 GB and all, it is still processing all those things. If you add one more RAM slot on top of that with the 8 GB or something, and increase the CPU cores and all those things, then you don't need to purchase the another VM to install all the components and all. It's like we are adding more CPUs or RAM storage in. It's like you're upgrading the existing system with a faster CPU rather than installing a new machine and doing all those things. So advantage, it is simple. It's like managing a simple and more powerful machine rather than maybe simpler than managing multiple machines. So in horizontal scaling, we are purchasing separate machines, whereas in vertical scaling, we are only purchasing the components like the CPU and the RAM, which involves lesser cost, and it will require the lesser space also, and the licensing cost will be more effective. So and each has its own limited limitations. Like say you need to, let's say if you are increasing your in horizontal scaling, you will keep on increasing your systems and all. So for that you need to increase your network bandwidth, you need to invest in network, you need to invest in spaces, and you need to invest in purchasing cost for the VMs or the physical hardware, and you need to invest in antiviruses, and you need to invest in maintaining those installed instances and all those things. Whereas in vertical scaling, right, you assume that you are getting a load up to 16 and the maximum capacity of your system is 16 GB only. So what if the load has increased for the 16 GB? So you can't add more space to that or more power to that machine. So in that cases, that results in downtime. So you need to choose wisely like what you wanted to do. And the complexity in horizontal horizontal scaling. So let's assume that today you have two systems, okay? Or assume three. So for this, the load to evenly distribute between yourselves, what you need to do, you need to form new clusters, or you need to invest in load balancers, and you need to do the data consistency and make sure that the data is same, and they both are having all the resources distributed between themselves and all those things. But in vertical it is like it's simple to make maintain, because we'll be having only, we are increasing the CPU power and we are not bothered about whether the data is shared between themselves. But it can become complex if a single machine cannot meet the performance requirements. So, and fault tolerances. In horizontal scaling, fault tolerances can be easily handled, because let's say if you have four systems now, you have performed the horizontal scaling and that, and for some reason the load in one of the CPU increased, and the remaining nodes are silent. In this case, the CPU one, the system one will go down, but still you have three other systems processing the same data. So even if something is down, the other systems will process the same data. So redundancy is easily achieved in horizontal scaling. But whereas vertical scaling, the point signal single is a single point of failure where you have the capacity to increase, but if it increases if you are getting a load which is more than the estimated load, then your system will go down. It will affect the entire system. And elasticity. So horizontal scaling, it is more elastic as we add more resources, or we can remove the resources based on demand. So whereas in vertical scaling, it is less elastic as it involves a downtime or a maintenance window and all those things. So when you make a choice between horizontal and vertical scaling, it depends on various factors such as the nature of application, what is the expected growth, and what are the cost considerations, and what's the existing architecture. So in generally what people do is they perform both horizontal scaling as well as vertical scaling. Like they purchase three or more systems and install all those things. And then instead of, let's say if the load is increasing in one of the node, and they see that they take that, okay, since we already have these things, so let's increase the memory and CPU storage in all the systems so that it handles the a new load that is coming in. So that is one way where you can use horizontal and vertical scaling. But the important factor is these decisions need to be taken before starting a project, rather than burning your hands in the project saying that, okay, we should have taken that, we should have taken this. So taking crucial architectural decisions before starting the project is a key factor in the success of the project. Thank you.